Hello and welcome to another video, and in this one we're going to talk about how to render multiple triangles in a ray tracer, as well as rendering a sphere and have it animate. So yeah, this is what our end goal is. But before we do that, um, Dr. Riggs mentioned there's an error in the rasterizer, so we're going to take a look at that first. Um, I'm not gonna pick up from the code that we have been doing in this video series, just because it'll be easier to show with what Dr. Ricks um, has had. And in here, we're just gonna go to our GitHub page for our class, and we have our Rasterizer 2.0 done. So we're gonna click into this. There's three commits. I'm gonna go to this old one. This is where I picked up my code from. Um, so yeah, it's already ready, and here it is. There's one change in here, other than the error that we're going to talk about, and that is in the fragment shader. He has added this ambience, and then he adds it to our UVX times D, and then he adds that. Same goes here, and then he adds it with the D here as well. Um, and that's why if we go here, it looks like this. It has that um, square in the back. So what we're gonna do is we're gonna fix this issue, and the issue is that um, at the beginning, the near and far plane is what the issue is. There's an issue with like being near or too far the plane, and if you're too far, you can't see, and if you're too close, you can't see either. Um, and I'm gonna kind of illustrate this in Blender. So if we go to Blender here, General, it's gonna be really simple. We're gonna press our I don't exactly know what this key is called, and this will pull up your camera view. Oh, I can just show with our, 1 second, go back to view selected. Alright, go here, screencast keys, you got that. Now, press N. Now we press that key right there. I don't remember the name of that key top of my head, but yeah, we click on our camera here, and then we set this clip start to 10. So basically just clips, as you can see right here, just clips into that. Um, that's kind of the issue. So that's what we're gonna try to fix, and it's a really quick fix, and I hope it's easier to kind of see it in Blender. So we're gonna go back to our code here. Uh, First thing is in our positions, we need to change this to -2, -2. But more than that, the issue is in the projection matrix, where in projection matrix index 10, we need to change this to 1, and this is for far plus near. I guess comment it. Far plus near divided by far minus near. Right? Then we're gonna add another line here, and it's for index 14, and this becomes -2. This is because it goes 2 times far times near divided by far minus near. And if we go look at our, this is how it should look, like Dr. Ricks mentioned. So that's the fix that is for the rasterizer. And so now we're like completely done with that. So let's move on to our ray tracer. So we don't need that anymore. So we're trying to replicate. This is what we left off with last time. So if we go back here, let's close out of this, this, and then we'll go into our ray tracer. This was from where we left off for the rasterizer. But yeah, let's focus on um, our ray tracer. So close this. All right. First thing we're gonna focus on is trying to render multiple triangles. So with that in mind, there's a fix that we need to do, which is in the minus or subtraction function. P1 comes first, then P2. We subtract P. Do that. So we're gonna go ahead and fix that real quick. That's something, another issue we had in our code. It's not as much of an issue. It's just that it'll work fine for triangles, but when it comes to spheres, it's not gonna work correctly. So we might as well go ahead and fix it now. Um, and then the next thing is, if you remember when I was talking through the coordinates of the y coordinates, they were upside down compared to what we did in the rasterizer. And that is because we need to flip the y from being y down to y up. So to do that, we go to this y3 here. We're going to put a -1 times, and then put this in a bracket. And now that's sort of fixed. Um, and yeah, first we're going to do a little bit of setup before we kind of get into the code section of it for the triangles. Um, one of the biggest issues with our code currently is everything is fixed. We like set it fixed. Now we need to make it more dynamic so that when we had more triangles, it works correctly. Um, this is not more of a fix. This is just me just changing the triangle coordinates to follow what Dr. Riggs went over. It's just so it's easier for you guys to follow as well, and it mirrors what Dr. Riggs goes in class. Um, as this is a little bit more complicated than what we have done before, so I would like to try to simplify it and easy for you guys to understand. So I'm just changing it to these coordinates, and you'll kind of understand as we look at them later. Let's see. Let's go see what it renders for us here. Perfect. So we have one triangle here, a red triangle. The goal is we render another one, the green one over here. I guess the green one and then the red one behind it. So let's go ahead and try to do that. So we have our first triangle. We're going to copy this, paste it. We're going to call it triangle 2. And then I'm going to adjust these coordinates um, to make it go behind the other one. And then obviously show up on the other side. So change this from negative to positive. Change this to 0. And change this to 1. Right. That should be it for our triangles. Our vertex A, B, C, A, B, C for both our triangles are set up. So now we can so in order to do multiple triangles, we're gonna put them in little objects here. So we're gonna call it const triangle spec geometry. So with this, we're gonna pass in the vertex to geometry triangle, and then here we're gonna pass in the color. So I want to make the left one green, or the first one, whatever you'd like to, however makes sense to you. So we got that. Next, we're just gonna copy paste it. If I can copy the whole thing, put it here. We're gonna call this 2. We're gonna call this 2, and we're gonna change this color to red. Second triangle with red color. All right. There's one more thing that's still left to do in this setup. That is putting them in a array for to deal with multiple triangles. So we're gonna call it const triangles. We go triangle spec 2. Perfect. We have those in there. So next thing to do is we're gonna go down. We need to make a for loop so we can loop through these. And where we're gonna make it is right after we, get the direction of the ray through this pixel. So that's what we do here. So right after we do that, we're gonna go ahead and make a for loop. We're gonna do let triangle spec of triangles loop through that array we made, and then we're gonna do let triangle equal triangle spec dot geometry. There you go. So here we'll just get the geometry, but we need to move all of this stuff here um and into the for loop. So we're gonna copy this and then move it here. So if we go right here, okay. So we have this in here. I just need to indent it in. All right, perfect. But there's an issue, and this is with what I had said previously. That's something that we need to fix. Is a lot of our things are very like when we set it up for the initial ray tracer of just one triangle, it was like everything was fixed like right here with this n. So we need to change this to get the cross product of v0 and v1. But then we don't do that yet. So we're gonna move up the code that gives us v0 and v1. We're gonna take this, then go there. All right. So now we get v0, v1, v2, the cross product v0, v1 for our n to get the normal vector. Now that that's done, right here we do an else. So we color the like if we set the background color to black, but we're just gonna go ahead and do it above. So I'm gonna copy this. We're not gonna use this else statement. We're gonna move it up here. That's the first thing we're gonna do once we enter this for loop. Make the whole thing black. So next, now we got that. We're gonna change this right here. We're gonna change this to just get it from our triangle spec since we set it up there, which is pretty convenient. And let's see what it looks like. You don't get anything. Okay. I'm not gonna entirely go through and debug as that'll take a lot of time in this video, but I'm just gonna show a handy function or like a if statement that Dr. Rick showed that you guys should use when coding this. So I'm gonna do if px equals 0 and py equals 320. Oh, why did it do that? All right. So in here it's for debugging, and we're gonna set a log message to the console to confirm this specific pixel is being processed. That's what this is for. So we're gonna do console.log. We're just gonna type debug. All right. So it's easier to do it one up here, and then we're gonna do one down here outside of the for loop. So we're gonna go outside of this for loop. Um, Very similar to this. So we copy the if statement. We want the if statement from here, but then we need this part of it to go inside the if statement. I'll explain that here in a second. But then we're just gonna change this to black. And so what this does is it marks the pixel and its surrounding area 10 into 10 block in black on the canvas. And this will help, visually identify the pixel that is being debugged. Here we set the color to black. Here we're going to make this a 10 out of 10 block, starting at PX, PY. All right, so our debug statements are set up, which is pretty nice. So next we're going to go, I believe there's two more things that we need to add, and that should get our multiple triangles rendering. Maybe we'll just go in here and check. Maybe I misspelled something. Ah, I knew it. Okay. Line 101, triangle 2 is not defined. Okay, let's go back to our code. 101. Triangles, triangle 2. I misspelled it here. There we go. Triangle 2. Let's see. Refresh. Triangle spec is not defined. A lot of misspelling. Triangle, 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 triangle spec dot geometry. Let's see. There we go. Our debug statement shows up, and we got our triangles rendering. We have multiple triangles rendering now. We're not quite done yet, though. So the next thing to do is to get a large value, and the easiest way to do that is use the number.maxValue function. And so this will help us track the nearest intersection distance, and we're going to put it right after we normalize. We'll do let equals nearest distance and set it equal to our function, the number dot max value. So we got that, and then we need that to check here. So um, let's see. If we go here, we need to go here, and we need to check if the nearest distance is less than t. If so, then we want to continue because we want to skip if a closer intersection exists. And then it will set the nearest distance equal to t. If it's not less than t, then we'll set it equal to t. Alright, there we go. Okay, everything is still working fine. The next thing to do is to check if the point is inside the circle, or the triangle. I'm getting ahead of myself, or the sphere, but I'm getting ahead of myself. But yeah, we're still in the triangle part. Um, Instead of doing it like the fixed way, we're gonna take the dot product of our normal vector, which is dot normal, and then pass C0, which is the cross product from edge AB. So C0. And the big to note is we need to make these less than, we need to switch these operators. So we're going to go ahead and do that real quick, and then we're going to replicate this. And then change this to C1 and C2. Alright, now our triangle should be done. I wanted the green one to come forward. Let's see. We go back up. We have our triangles here. Maybe I messed up with the coordinate. -1. That's our first triangle. Our second triangle is 1, -1, -0.75, 1, 0, -2, 1, -0.75. Alright. So the next possible cause is we look at here. Did we set everything up correctly? Triangle 1, triangle 2, color red, constant triangles, triangle spec, passing the triangle spec 1, triangle spec 2. Then we go here, we have our debug message. Um, we set the whole thing to black. We fix this where we have the Y flipped. Then set the nearest intersection distance, the triangle spec of triangles. So yeah, some good debugging practice. Cross product. I believe I need to switch this, not that it should matter. Just for consistency's sake. Ooh, 7. It's taking a second to render. Let's see. Did I put? Oh. Interesting bug. That's looking good. Triangle spec. V0B1. We gotta change this. Triangle 0. Add O. Reset this equal here. Alright. Alright. Well, it was a small error. It's because I misspelled continue here, or I backspaced somehow. But that was why it was not rendering all the way. As you can see now, we have our triangle setup. Got our first part done. So we have one more part left. That is, first we're going to try to render the sphere, and then we're going to animate it. So I guess two more parts, um, but it all has to do with spheres. So let's try to get that going. Um, what I'm going to do before uh, I guess we're going to first do the setup for the spheres. And as part of that, I want to make an empty array so we can clear out the triangles because I just want to focus on rendering a sphere on there. So I'm going to comment this out. Right? Now we're going to set up, just like how we set up our triangles here, we're going to set up the spheres. Or I guess just one sphere. So we're going to do const sphere spec. We're going to get straight into that, setting up the object geometry. It's pretty simpler, a lot more simpler than our triangles. So we're going to set the sphere with the center of 0, 0, -1, and the radius of 1. But eventually we're going to put it at 1. I'm going to put it at 0.5 right now, so it's easier for us to see that, hey, we are got a sphere on our thing working correctly. So, and I'm going to do yellow. Do whatever color you want. And then we're going to have to do an array of spheres. So we're going to do const spheres equal spheres back. So now that's set up. So our setup is done. Now, what we have to do is loop through our spheres, but it's just one. But obviously, setting this up will help us in the future when we want to add more than one sphere. So we go here. We're gonna do a classic for loop for let sphere spec of spheres. Let's pray to God I don't have no more misspellings. uh, First thing, we're gonna get our spheres geometry, so the center and radius, we're gonna get that here. And then we're gonna get the sphere center. So let center equals capital C, I would like to go with center equals, put it in a little array, sphere X, sphere Y, sphere Z. There you go. Got our center. Now we need to get the radius. Let R equals sphere 3, 0, 1, 2, 3. That's the fourth element in our array that we set up earlier. Now that we got that, we're going to compute the quadratic equation for ray sphere intersection. This is something that Dr. Ricks went over in class. He went behind the math behind it, and so this just, again, just like how for triangles, just translating that, putting that into code form. So I highly suggest that, you paid attention in class, and he also put this picture of his notes in the should be in the GitHub or the class canvas. So there, check it out. It works in tandem, understanding that will help you understand the code. So yeah, let's code or compute the quadratic equation for ray sphere intersection. First, what we're gonna do is we're gonna get the vector from sphere center to ray origin. We do that by let d equals minus, use our minus function. We're gonna pass in our O, that is from here, which is our camera origin. So we're gonna pass that in here. And then we're gonna pass in the center of our sphere. Next, we're gonna get the linear term, and that's by setting let b equal 2 times dot r comma d, and r is this. We get the ray direction normalized, and then d is this that we get from here, which that is the vector from, for the sphere center to ray origin. So that calculates our linear term. Next, we go let c, capital C equals, we do the dot product of our the vector minus the radius squared. This gives us our constant term. The next part is getting the discriminant. So let discriminant be squared minus 4 times c, which is the constant term. Then we check if, then we're gonna do no intersection if the discriminant is less than 0. So we're gonna check if the discriminant is less than 0. If so, then no intersection. So we can go ahead and continue. Then if there is, then we do let t, then we're gonna get our first solution and second solution. So what we're gonna do is there we go. So if the discriminant is greater than 0, then there is intersection, and we're gonna do let t0, which is our first solution, t0 equals minus b, which is our linear term, minus mat dot sqrt square root of the discriminant. And then we just copy this for the second solution. But we do an addition here instead. That's the difference. And now we just do an if else, or if and then else if. So we check if our t0 is greater than 0. If so, then we're going to set our t equal to t0. Use the closure intersection. That's what we're, doing here. But then, if t1 is greater than 0, we're going to set t equals to t1. This is saying that you use the farther intersection. So, that is good. Next, we're gonna do if if it is not t. So skip if there's no valid intersection. That's what this line is doing. Next, using our nearest distance, we'll skip if a closer intersection exists. So the same thing. So we can just go ahead and copy that actually. Save us some typing because we've been typing a lot. And then finally, we can go ahead and copy this as well. Copy our filling, which is, color the pixel based on the sphere's color. But that's why we need to change the sphere. And then let's go see what do we get. Oh, they might have typed something wrong. Whew. Uncut, cannot read properties. Line 163. Ooh, okay. So maybe I didn't spell something wrong, but I incorrectly placed the code. Let's see. Alright. You might ask how I got it working. Well, it was another one of my misspellings. I spelled geometry wrong here. Geometry. There we go. We finally have a sphere rendering on our screen. So now we can go back and we can have our triangles render with it as well. So I'm going to uncomment this and comment this. And let's go check it out. There you go. We have our triangles and our spheres. So the last thing we have left to do is animate our sphere. To do that, I want to go back up here to kind of where we do our setup before our double for loop. And I'm going to set a time variable for the animation called let time equals 0. Next, we're going to put all this that we did in a render function to draw the scene. So I'm going to make a function called render. And then I'm going to do a little line that moves the sphere along the z-axis for animation. Like, if you saw in the beginning what our end goal was, it starts from like in our face and then goes back out. So that's what's going to happen here. Z minus equals 0.1. And yeah, like I said before, this will move the sphere along the z-axis for the animation. Before I do the animation, one thing to mention is the way we did the sphere was the code will solve a quadratic equation to determine if the ray intersects the sphere. That's how we were able to get that sphere. And if the ray does intersect the sphere, then the pixel is colored based on the sphere's color, which we picked was yellow. Um, and the nearest intersection was if multiple objects intersect the same ray, the code will ensure that only the nearest object is rendered by keeping track of the closest intersection distance. So that's what this line and this is about. Um, so yeah, with that kind of said, I'm sorry to jump into that randomly. I just kind of wanted to recap on what we did before I get into the animation. Um, yeah, let's make our simple animation effect. What we're gonna do is go back to our render function, and so we're gonna have this show up at the end, which is to increment time for animation. So we're gonna do time plus equals 0.1. So all the code below will go in between this line and this line. And the next, we're going to schedule the next frame. So we're going to use a set timeout, render, call it render function 0. But then we need to start the rendering loop, and so we need to do that same line out here. Alright, now I think we are ready to move our code, so we'll just copy this from here and go to this line and then paste it. I'm gonna have to indent it and do, yep. Alright, let's go and see what happens. Hopefully it works. Okay. One thing that I didn't mention earlier was, you know how I set it to 0.5 here? I want to make it 1, and then that should make it start in our face. There we go, it worked. All right, we were able to, get our ray tracer working. We were able to render multiple triangles now. So all you have to make is kind of set up the triangle coordinates, put it in the object, and pass it in the triangles, and now it'll um, be able to render multiple triangles, which is really convenient and not have to, individually do that. I know you have to do some setup in the beginning, but after that, our code is a lot better now that, it's not fixed like it was before. Um, and then we can render a sphere, and not only that, we can animate it to move along the z-axis over time. Uh, so yeah, that's all I got for this video. I hope this kind of made sense. I know um, maybe I was kind of jumping around a lot of places. First going with the rasterizer, then jumping back into the ray tracer. But I hope that I was trying to break it up into parts. So the three different parts that we had: rendering multiple triangles, rendering a sphere, then making the sphere animate, and having them all coexist in a scene. So yeah, so there's not much code, I guess. Other The main part was really this for loop for the sphere, how to render a sphere. That's really the main thing of um, new thing in this video. So definitely refer to the quadratic um, equation and that Dr. Ricks went over, and this should make a lot more sense. So yeah, that's it for this video. Thank you.